Welcome to the deep dive. You sent us down a fascinating rabbit hole with this document on the Jetson virtual channel and the GMSL camera framework.
Yeah, it's pretty dense stuff.
Totally. So we're here to unpack how you can connect multiple cameras to NVIDIA's Jetson TX2 and AGX Xavier platforms. Pulling out the crucial insights and making sense of the technical details without getting totally bogged down.
Right, our mission is basically to shine a light on the clever engineering that makes these advanced vision systems actually work.
Exactly. This guide, Jetson GMSL Camera Framework Guide, nv.pdf from June 2020, right? That's our roadmap.
Yep, it details how these Jetson boards ingest data from loads of cameras using something called GMSL, Gigabit Multimedia Serial Link. We'll look at the hardware, those serializers and deserializers.
Maxim's MX9295 and MX9296 specifically.
Right, those ones. And the software that makes it all run, plus how these virtual channels get configured.
So whether you're gearing up for a project with embedded vision or just trying to stay ahead on camera tech, or maybe you're just curious how these complex systems tick.
Which is fair enough.
Yeah. This deep dive is for you. We're really aiming for those aha moments, the bits that reveal the ingenuity hiding in this tech guide.
Sounds good.
Okay, so let's start right at the foundation. The GMSL protocol itself. What's the deal there?
Well, what's interesting right off the bat is that GMSL, Gigabit Multimedia Serial Link, it wasn't initially dreamed up for systems like the Jetson.
Oh, really?
No, it actually came from Maxim Integrated, and they built it for the automotive world, specifically for things like ADS, Advanced Driver Assistance Systems, and CMS, camera monitoring systems.
Ah, like the surround view cameras on newer cars.
Exactly like that.
Yeah.
And this focus on reliability and signal integrity, which is obviously super critical for safety in cars, that translates directly into benefits for other embedded stuff where, data loss or interference could still be a big problem, even if it's not life or death the same way.
Okay, automotive roots. That makes sense then, why the document keeps talking about robustness and dealing with electromagnetic interference, EMC.
Precisely. GMSL is built on SerDes technology. That's just shorthand for serializer deserializer.
Got it.
So on the camera side, you have a serializer chip. It takes the parallel video data coming off the sensor and converts it into a really fast serial stream.
Okay.
Then that stream travels down a cable to the Jetson platform. And on that end, there's a deserializer chip that does the opposite, converts the serial data back into a parallel format that the Jetson's processors can actually understand.
And this all happens super fast, right? The guide mentioned something like 6 gigabits per second.
That's right, up to 6 gigabits per second. It's built for high-throughput video. And another big thing, also from those car origins, which is great for embedded systems in noisy environments, is the type of cable they use.
Right. You mentioned that STP or Quirks.
Yeah, shielded twisted pair, STP, or coaxial cables. They're not just cheap, they're also really good at resisting electromagnetic interference. Helps keep the data stream clean.
So the basic picture is, camera has a serializer chip, sends data over a tough cable, and it's received by a deserializer connected to the Jetson. High level, that's it.
That's the gist of it, yeah.
Okay, but how do you actually build a multi-camera system with this? The guide talks about a reference setup.
It does. The document details a reference GMSL setup that NVIDIA actually validated on the Jetson TX2 and AGX Xavier. They use Sony IMX390 image sensors for this.
Okay.
So in this setup, they paired 2 of these sensors. Each sensor was connected to its own MX9295 serializer chip.
One serializer per camera.
Right. And these sensors were set up to stream 1080p video at 30 frames per second using a raw 12-pixel format. That data went over 2 CSI MIPI lanes for each sensor.
2 cameras, each with its own serializer, each using 2 MIPI lanes. Where does it go from there?
So the output from those 2 MX9295 serializers then connects to just one MX9296 serializer.
Ah, okay. They converge.
Exactly. The connection uses the GMSL ports on the deserializer. One serializer plugs into one GMSL port using those Quirks cables we talked about. Then that MX9296 deserializer connects to a CSI port on the Jetson, either a TX2 or an AGX Xavier. The guide uses CSI port A as the example.
Okay, hold on. If you have 2 different video streams coming into the Jetson through the same physical CSI port, how does the system tell them apart? This sounds like where virtual channels come in.
Bingo! That's the key piece right there. To handle multiple streams coming through one port, the deserializer assigns a unique ID to each stream. It's software configurable, this ID. Think of it like different lanes merging onto one highway exit. Each lane needs its own marker so traffic control knows where cars came from.
So it's like a software label for each camera feed.
Pretty much. This virtual channel ID gets set up in software using the device tree. We'll definitely get more into that later. The absolutely critical thing is that the ID the deserializer assigns must perfectly match the ID that's programmed on the Jetson side for that specific video stream.
Right, they have to agree. Hardware and software need be talking the same language, basically.
Okay.
The document calls this setup a 2x aggregator. Is that just fancy talk for what we just described?
Yeah, it's just another term for it. Because that one deserializer is aggregating the streams from two sensors, they call it a 2x aggregator setup. The guide also throws out the idea of a 4x aggregator.
Which I guess, following the pattern, would let you connect 4 sensors through one CSI port.
That's the idea. The document outlines how you could potentially use a 4x deserializer chip. You'd have up to 4 sensors, each with its own serializer, connecting to this 4x deserializer via 4 separate GMSL links. Then the output of that big deserializer would go into a single CSI port on the Jetson, and each of those 4 incoming streams would get its own distinct virtual channel ID.
Wow, okay, that really opens the door for packing a lot of cameras onto one Jetson board. Now, zooming out a bit, what are the overall limits or capabilities of these Jetson platforms with CSI and these virtual channels? How far can you scale this?
Well, the document gives some pretty interesting numbers on the maximum sensors these Jetsons can handle using these aggregators. The Jetson TX2, for example, can handle up to 12 sensor connections if you use aggregators.
12 cameras on a TX2?
Yeah, and AGX Xavier, it goes even further. It can support up to 16 sensors if you're using its internal image signal processor, the ISP, or get this, up to 24 connections if you bypass the ISP.
24 cameras. That's a lot of eyes on one board.
It really is a huge amount of visual data processing potential.
And this scaling relies entirely on these virtual channels working correctly. Does the guide say how many virtual channels each platform actually supports?
It does. The Jetson TX2 can handle up to 12 virtual channels. You'd achieve that by using 3 4x aggregators, with each one connected to one of its CSI input interfaces.
Okay, 3 aggregators, 12 channels total.
Right. And the AGX Xavier, being more powerful, supports either 16 or 24 virtual channels, again, depending on if you're using the ISP or not. The reason it can handle more is because the Xavier has 4 independent CSI input blocks, sometimes called CSI bricks.
CSI bricks.
Yeah, think of them as like separate, independent entry points for video data into the Jetson's processing system.
Got it. So whether it's a 2x or a 4x aggregator feeding into a port, each individual camera, identified by its virtual channel, looks like a totally separate camera to the software, right? And mentioned V4L2.
Exactly right. Inside the Linux software running on the Jetson, each camera stream, thanks to its unique virtual channel ID, just shows up as a standard independent V4L2 device that's Video for Linux 2.
Yeah.
And what's also really important for processing efficiently is that each frame of video coming in from these different virtual channels gets sent to its own dedicated spot in memory.
Keeps things neat and tidy.
Keeps the streams separate and manageable for whatever application needs to use them downstream, yeah.
Okay, so we've got the GMSL protocol, the basic hardware bits, serializers, deserializers, and how virtual channels let multiple cameras share one pipe into the Jetson. Let's dig into the physical connections for that reference 2 sensor setup they described.
Sure. Figure 7 in the guide shows it pretty clearly. You've got the 2 Sony IMX390 sensors. Each one has its MIX9295 serializer physically located right near it, probably on the same little PCB.
Makes sense. Keep the initial path short.
Right. Then you have those GMSL coaxial cables running from each serializer to the MX9296 deserializer board.
And how does that deserializer board actually connect to the Jetson?
It interfaces with the Jetson, the TX2 or AGX Xavier dev kit through an MIPI adapter board. And it uses those standard white MIPI ribbon cables.
Ah, the flat white ones.
Yeah, those ones. They plug right into the camera connector socket on the Jetson board. The guide does mention, though, that this is just one way to physically arrange the aggregator hardware. And also the whole GMSL setup needs its own external power supply. It doesn't run just off the Jetson's power.
Right. External power. Good note.
Yeah.
So it's a mix. Specialized GMSL links between cameras and the aggregator, then standard MIPI from the aggregator to the Jetson.
That's the picture.
Okay, now let's flip over to the software side. How does the Jetson's OS, its drivers, actually understand and talk to all this GMSL hardware and these virtual channels?
Right. This is where the software framework gets critical. Figure 8 in the guide shows this. So besides the driver for the actual image sensor, like the IMX390 driver, There are separate kernel drivers for the serializer, MX9295, and the deserializer, MX9296.
Okay, separate drivers for each component.
Yeah.
Modular.
Exactly. And the interesting thing the document points out is that the sensor driver acts as the main interface for the rest of the system. It kind of looks and feels like a regular V4L2 sensor driver you might use in a simpler setup.
So the complexity is hidden.
Somewhat, yeah. All the communication and setup for the series chips, the serializer and deserializer happens under the hood, managed by that sensor driver. As a developer, you mostly just talk to the sensor driver and it handles the GMSL details.
That's a useful abstraction. The guide also says the SerDes drivers aren't directly programmable by users. Why is that?
The reason they give makes sense. There's a very specific, often timing-sensitive sequence you have to follow when talking to the SerDes chips. It doesn't really fit neatly into the standard V4L2 way of doing things, which is designed for simpler sensors.
Okay.
So basically, to keep the GMSL link stable and make sure it works right, and to stop people accidentally messing things up, they keep the SerDes drivers as separate kernel modules. Only the sensor driver talks to them directly. They don't expose APIs to user applications.
Makes sense. Don't want random commands messing up high-speed data.
Now, the guide talks about this CLEMS link AKECT structure. What is that and why is it so important? The GMS link TX structure.
Yeah.
There's like the central software piece that holds everything about the GMSL link configuration for one specific sensor. It's a container for all the vital info, the virtual channel IDs, source and destination, which CSI ports are being used, the type of GMSL linked, how many video streams are active, how the CSI data lanes are set up, the deserializer CSI mode, and really importantly, the I2C slave addresses for both the serializer and the sensor connected to it.
Whoa, that's a lot of parameters packed into one structure. Where does all that info come from?
Most of it gets filled in by the sensor driver when the system boots up. It reads this critical info from the GMSL link node inside the sensor's device tree entry. Again, we'll get to device trees. Yeah. Some bits might also get filled in dynamically by the serializer and deserializer drivers themselves as they initialize. Once this GMSL link X structure is all populated, the sensor driver hands it over to the SerDes drivers. And they use that data to do essential stuff like powering things on and setting up the control paths and the high-speed data streaming.
Got it. The guide also gets into physical versus proxy I2C addresses. This sounds like it tackles the problem of having multiple identical cameras.
Exactly. If you have, say, two IMX390 sensors in your GMSL setup, they both come from Sony with the same default I2C address, their physical address. But on an I2C bus, every single device needs a unique address so the system can talk to it individually.
Right. Address conflicts are bad.
Very bad. So proxy addresses are the solution. These are unique I2C addresses that you define statically in the device tree. When the system boots, the drivers first use the known physical addresses to find the devices. Once they've found them, they tell the devices, okay, from now on, respond to this proxy address instead. And all future communication uses those unique proxy addresses. It neatly solves the conflict.
Ah, clever. So it's a software trick to distinguish identical hardware on the same bus. What about booting up and turning streams on and off? How's that managed?
Power management, as Figure 9 shows, is mostly handled by the deserializer driver.
Why the deserializer?
Well, it's the central hub, right? All the sensors connect to it. An individual sensor driver doesn't necessarily know about the other sensors sharing the same deserializer. So when one sensor driver asks to power on, it's the deserializer driver that actually coordinates powering up the whole GMSL module.
Okay, makes sense. Central control.
Yep. And similarly, for starting and stopping streams, Figure 10, the commands from the sensor driver get passed to the serializer, but the deserializer driver coordinates the actual start-stop across the GMSL link to keep things synchronized. Stream setup involves the SerDes drivers configuring their internal paths before data starts flowing.
Okay, let's dip into the SerDes driver API specifics.
Yeah.
The guide lists key functions for both chips. Can you highlight a couple of important ones for the MX9296 deserializer?
Sure. For the MX9296 deserializer API, you've got obvious ones like MAX9296 power on and MAX9296 power off. Pretty clear what they do. MAX9296 def register is crucial. That's how a sensor driver tells the deserializer, hey, I exist and I'm connected. The deserializer checks compatibility and stores the sensor's GMSLink DEX. Then there's MAX9296 setup control, usually called at boot time to configure the deserializer itself, often setting it up to handle multiple incoming streams. MAX9296 setup link is interesting. It can temporarily put the deserializer into a mode where it only talks to one specific sensor serializer pair. This is sometimes needed for initial I2C setup or overrides.
It's like a direct line for configuration.
Kinda, yeah. And finally, Max 9296 start streaming and Max 9296 stop streaming do exactly what they say, start and stop the data flow, triggered by the sensor driver.
Okay. And on the other side, the MX9295 Serializer API. What are its key functions?
For the MX9295 serializer, Max 9295 reset control resets it and clears any temporary I2C overrides. Max 9295 instead pairs how the sensor driver logically links itself to its specific serializer chip. Max 9295 setup control is vital. It powers on the serializer and, importantly, does that I2C proxy address assignment for both the sensor and the serializer itself.
Ah, that's where the proxy addresses get programmed in.
Exactly. And you need to make sure the deserializer is in that exclusive link mode we just mentioned before calling this, so the I2C communication works. Lastly, Max 9295 setup streaming configures the serializer's internal data path, getting it ready to send video from its paired sensor.
It sounds like a very specific dance the sensor driver has to lead, calling these APIs in the right order to get the whole link up and running.
It really is a carefully orchestrated sequence.
And now we keep mentioning the device tree. The guide spends a lot of time on device tree programming. Why is this so absolutely critical for GMSL cameras on Jetson?
Oh, the device tree is everything. It's the fundamental way you describe the hardware connections and the static properties of all the devices to the Linux kernel. Without a correct device tree, the OS literally wouldn't know the cameras, serializers, or deserializers exist, how they're wired up, what their I2C addresses are, physical and proxy, or how the virtual channels should be routed. It's the blueprint.
The system's hardware map, essentially.
Precisely.
Yeah.
And the document breaks it down nicely into the platform device tree, the module device tree, and then it touches on the plugin manager and camera modules device trees too.
Okay, let's start with the platform device tree.
Yeah.
What GMSL-related info gets configured there?
The platform device tree defines the basic hardware connections and the initial addressing. This is where you declare both the physical and the proxy I2C addresses we talked about.
Right, defining the addresses.
So for that reference setup with two Sony IMX390s, even though they both have the same physical I2C address from the factory, like 0x1A, the platform device tree assigns them unique proxy addresses, maybe 0x1B and 0x1C. Same goes for the MX9295 serializers. If they share a physical address, like 0x62, they get unique proxy addresses too, like 0x40 and 0x60. And the physical address of the MX9296 deserializer itself is also defined here.
The guy shows an example node, TK9546 at 70. What's that? And why are the GMSL device nodes nested under it?
Good catch. The TK9546 at 70 represents an I2C bus expander or multiplexer chip. In the reference hardware, the GMSL deserializer connects to the Jetson's camera port via that MIPI adapter board, and that adapter board has this I2C expander chip on it.
So it's an intermediary.
Exactly. So in the dice tree, all the nodes for the GMSL parts, the deserializer, Max 9296 at 48, the serializers, Max 9295A at 40, Max 9295B at 60, etc., and the sensors, IMX390A at 1B, IMX390B at 1C, they all live as child nodes under this I2C expander node. You'll see standard stuff like compatible tells the kernel which driver to load, and reg specifies the I2C address, usually the proxy one.
Right.
But crucially, you also see these NVIDIA-specific properties like NVIDIA GMSL VESA device and NVIDIA GMSL device. These explicitly link the serializers to their deserializer and the sensors to their serializers. The def add property usually holds the sensor's original physical I2C address.
Got it. Moving to the module device tree, what's its job, especially with virtual channels?
The module device tree adds configuration specific to the camera module itself, and yes, this is where virtual channel assignments are defined. Since the sensor driver is the main interface, each sensor device node in the module DT gets a subnode called GMSL link.
The critical GMSL link node.
Absolutely critical. It describes everything about the GMSL link for that sensor, source CSI port, destination CSI port on Jetson, DSC CSI port, which GMSL link it's using, SerDes link, CSI mode, SNAR mode, the sensor's default virtual channel, STVC, and most importantly, the destination virtual channel ID, VCI, that the deserializer will assign to this sensor's stream. Plus things like the number of data lanes, num lanes, and supported video format streams.
And the guide really hammers home getting that VCI'd property right, doesn't it?
Oh yeah, it's vital. For virtual channels to work, that VCI'd in the sensor's GMSL link node must perfectly match the VCID property in the corresponding CSI camera serial interface and video input channel nodes within the same module device tree file.
Consistency is key.
Total consistency, especially if you're using the Jetson's dedicated video input engine. The module DT also defines how the CSI and VI ports connect, using properties like port index and bus width. For the reference 2 sensor setup going into CSI port A, both VI and CSI channel nodes would probably have port index 0. Bus width would indicate the number of lanes for that channel.
What about the Tegra camera platform node mentioned in the module DT context?
The Tegra camera platform node holds high-level info about connected camera modules. For GMSL, the nums lanes property typically shows the number of lanes connected to the shared CSI port. So even with 2 sensors using 2 lanes each into one port, nums lanes might just be 2 here, unlike a setup with sensors on separate ports. Max lane speed is also set, considering shared bandwidth. And importantly, under the modules section inside this node, the individual sensor nodes are listed using their proxy I2C addresses, and proc device tree points to their full path using those proxy addresses.
Okay, and briefly, the plugin manager and camera modules device trees, what's their role?
The plugin manager DT additions for GMSL are pretty similar to any other camera. The guide has examples showing how the reference setup is added for TX2 and Xavier. For the camera modules DT, all the GMSL components on the I2C bus get defined, mirroring the platform DT, usually under the I2C at 0 node because of that I2C expander chip.
Right.
But here's a crucial point the guide makes about the camera modules DT. The default VCI in the VI port definitions is often just 0 for all ports. So you must explicitly override this with the correct unique VCI for each GMSL stream, either in the plugin manager DT or the sensor-specific module DT. Otherwise, the virtual channels won't route correctly.
Gotcha. Override the default VCI. That seems like a potential trip hazard.
Definitely something to watch out for.
Okay, that's a really deep dive into the device tree configuration. Clearly fundamental. Are there any major constraints developers should know about when using this GMSL tech?
One big one the document stresses. All sensor streams sharing the same CSI aggregator and port must use the same number of CSI data lanes.
Same lane configuration for all cameras on one aggregator.
Yes. If the deserializer driver sees a mismatch, it just won't register the new stream. Stops things right there. Beyond that, it also mentions that aggregators generally work best with identical cameras running at the same frame rate and mode. It's always smart to check the specific datasheet for your aggregator chip if you're doing something non-standard.
Good advice. Check the hardware specs. What about validation? What did NVIDIA actually test and confirm worked back when this guide was written?
So back in June 2020, they had validated dual GMSL sensor streaming. That means the 2 sensor setup, sharing CSI port A, was tested and working for both preview and capture using Argus and standard V4L2 apps. The 2x deserializer aggregator functionality was validated too.
But not the 4x aggregator.
Right. The guide explicitly says the 4x setup hadn't been formally validated yet, mainly because they didn't have the hardware module available for testing at the time.
Okay, good to know the status as of the document date. Finally, known issues. Were there any significant problems identified back then?
Yeah, they list a few. Some general ones were occasional flickering in the preview during big scene changes, and also that the sensor tuning and image quality weren't considered top-notch, yet suggesting room for improvement.
Okay, minor glitches and quality things. Anything platform-specific?
Yes. Specifically for the AGX Xavier, there was a hardware issue with the 1.2-volt power supply. Some older GMSL kits had a Max 1996 board that didn't draw its own 1.2V. And unlike the TX2 carrier, the Xavier carrier board didn't supply that voltage to the camera connector.
Oh, power mismatch.
Yeah. The workaround was to kind of hack it by using a spare LDO regulator on the Xavier board, one originally meant for SATA, to provide the needed voltage.
A bit of a hardware patch needed then.
For those older kits, yeah. And one last thing. A software issue with plugin manager board IDs. The reference GMSL module didn't have its own unique ID, so it was accidentally using the ID of the MIPI adapter board it connected through.
Causing conflicts.
Potentially, yeah. The temporary fix was to just disable the IMX390 module definition in other configurations that use the same MIPI adapter to avoid clashes.
Okay, these are definitely useful, practical gotchas for anyone implementing this. Well, we have covered a ton of technical ground here. Let's try and boil down the key takeaways for everyone listening.
Okay, quick recap. We looked at how GMSL, Gigabit Multimedia Serial Link, combined with virtual channels, lets you connect and manage lots of cameras on Jetson TX2 and AGX Xavier. We talked about serializers and deserializers moving that high-speed video data. We stressed how vital the software drivers and especially the device tree configuration are for telling the system how everything's hooked up and routing those virtual channels. And we touched on some limits and known issues from back when this guide came out. Hopefully it gives a clearer picture of how these complex camera systems actually work.
Absolutely. And it really does make you think about the possibilities, doesn't it? Having multiple high-res video streams pouring into one interface managed by these virtual channels just unlocks potential for really sophisticated applications. Robotics, autonomous vehicles, advanced vision systems. What kind of future stuff do you think this enables?
That's a great question to ponder. This tech provides a really solid foundation, and with sensors and processing power getting better all the time, well, the applications for aggregated high-bandwidth video are probably going to get even more interesting than we can imagine right now.
For sure. Well, this deep dive has really just skimmed the surface of the detail in that document. If any specific area caught your interest, device tree programming, SerDes protocols, driver development, definitely check out the original Jetson GMSL camera framework guide, nv.pdf. It's packed with more info.
Definitely worth a read if you need the nitty-gritty.
Thanks for joining us on this deep dive.